Now we will see another method of building the model. This will be sequential model, but it will be in a different way. Like, we will define the model 2 is equal to tensorflow dot keras dot layers dot sequential models dot sequentials, and in the sequential model we will define the layers. First we need a flattened layer, and the flattened layer input shape should be 28. Then we should have a dense layer neuron 56, and the activation is equal to value. Similarly, we can copy this and this, and it should be on 2, and I can set it as 240. And now we will have a final layer, dense layer, which will represent the output layer, and the activation function will be softmax. Now we will check the model summary as previous. So again we will fit this model 2 with the train. I can copy it rather. It should be model 2, and everything is okay. Sorry, I did not compile it yet, so I need to compile first. Model 2 dot compile. I can also copy it from here, as these are the same. So in the compile here, it should be compiled. Model 2 should be compiled with the previous one. Now I think it will work. It is working. So it also worked perfectly. Now I will show another method of defining artificial neural network model using TensorFlow, and this is called functional API. In this method we need an input layer. The input layer should be TensorFlow keras layers input layer. The shape should be 18x18. Now we should have a dense layer. We can define it as x dot keras layers. It should be dense layer, and its neuron can give it 56 activation ReLU as previous, and it should be passed by the input layer. Then again x, we will define another layer, another dense layer, and here we are putting on 112 neuron, and the activation function is value as well. Here we will pass the previous layer. You can copy it, and we will paste this 3 times. One is Here you can give 240, here we can give 150, and here it should be 10, and this is our final output layer. And here softmax. Now the model will be model 3. It will be tf dot carer dot model it should have input layer and output layer. The model 3 compile, you can copy it from the previous compilation, and it should be model 3. Now let's check the summary of the model. And it shows on 74. As here we did not use any flatten layer, so we will flatten our train shape. For this reason we will reshape it as none -1 28 28. Now 28 into 28. Let's check the shape. Yes, now it's compatible with the input layer, so I think it is okay. It's train, you can call it as functional API. Similarly, the same thing should be for the validation and test. Now we will feed the model 3 dot feed its input. I can copy it from here. Model, it should be model 3 extend function void train validation should be x validation function y validation. Now let's check it. It is also working as usual as the above models, but here we got the accuracy of the training set 76%. Here we got almost 80% in the first layer, and for the third layer, for the third model, we get 71%. And these differences happen due to the variation in neuron number and number of layers. So we have to practice more to optimize this number and layer, and we have to check it which layer, which number of layer and which neuron work better for our model.